My name is Halyna Oliinyk, and today I will be speaking about personal data identification for data science tasks. And first of all, before I will start my story, before I will start my talk, I'd like to say some words about the company I'm working in. So I'm working in Untitled. It is a data privacy cybersecurity solution that is a sustainable data discovery tool for privacy, security, and governance. So simply saying, what we are actually doing is that we are helping companies to protect PIIs from being stolen or from some kind of attacks that these PIIs might have. So also we are providing some business intelligence inside, we are providing governance, assistance, compliance, and so on. So what it means in practice is that we are helping companies to find out where they have their PIIs, how can they inventorize them. We are helping the companies to understand what kind of data they should protect, where it is located, and also we are helping them to protect it. And we are doing a lot of stuff that is related to data science, to AI, to different kind of machine learning fields, and obviously finding out where PIIs are located, where sensitive or personal data is located, is a data science task that our team, specifically I'm the head of data science team, and we're helping to do this task. So also before I will start more detailed and technical story, I think that it makes sense to say some words about GDPR. What is GDPR? What are GDPR main concepts, and so on. So speaking about this kind of regulation, it was created and got its power on the May 18th, and since that time a lot of companies struggle to actually follow GDPR. Specifically, this is more of a problem of bigger companies that are on the market for, I don't know, 30, 40, 60 years or even more. They usually have tons of clients' data and they don't know where this data is located, how can they protect it, and what should they do not to get fines and to comply with GDPR, CCPA, or other kind of compliance. So the first thing when you try Googling GDPR or CCPA, for instance, the first thing that you understand is that it is pretty complex from the legal point of view. And speaking about, following it, this is also not a very simple task, and GDPR document itself, it was created in a way that if the company complies with GDPR, it means that this company actually protects clients' data very well, and that it has the full cycle, whole process of understanding where the data is located, understanding how data is processed, done really well. So I think that it makes sense to start with some kind of basic GDPR checklist, just to understand what are the details of this kind of regulation. So first of all, speaking about lawful basis and transparency. So the company really needs to understand why does it use some kind of personal or sensitive data. So the company needs to understand why this data is stored inside the company, if it is really needed, because for many kind of forms, for instance, that clients should write down and they should fill up different kind of fields, a lot of these fields, they are actually not really needed by the company, because this is some kind of usual way, this kind of stuff, it is usually not being changed after years and years and years. And also to do that, it makes sense to conduct an information audit to determine what information the company is processing and who has access to it. So this kind of step, it is more related to getting groups, and specifically OneTouch is helping to do that. Speaking about data security, obviously this step is not an easy one, because actually to follow data security, first of all, after understanding where the data is stored, the company needs to make decision if the company needs to encrypt, pseudonymize, or do some kind of similar action to the data, if the data is personal. Speaking about this process, the company really needs to understand that data protection should be taken into account during all the processes that are happening to the data in the company. And what it means is that, like, in many cases, even the design and overall architecture of the company is being changed just to follow this data security need and data security kind of necessity. And also, obviously, this is not a very easy way because usually it affects performance and so on, and this is not a very simple step. And also, I will speak more about what is encryption, what is pseudonymization, anonymization, personal data, and so on. Another part I'd like to speak about is accountability and governance. And what it means also in practice in the majority of companies is that the company should hire some kind of data protection officer or data protection advisor, DPO or DPA. And it means that the company needs a person who will just, take into account where the data is located, that company is protecting some piece of data, and this person just need to understand the overall architecture of the system to be responsible for GDPR compliance and just to be able to give some kind of advices to the company in the cases when the company is not following GDPR in some cases. So this is overall about hiring some person that will help to follow GDPR and that will give some advices when it's needed, and this person will be obviously responsible for following GDPR. Also, speaking about privacy rights, it is a very important thing and kind of not an easy step for a lot of companies to give to the customers an easy ability to make requests to the company to find out where their personal or sensitive data is located. And what it means in practice is that, for instance, I'm a customer and I would like to know where, the network of hotels I'm usually staying in, what kind of data they have about me, where they store it, how they store it, like at least some information about it. And usually it's not an easy process because, first of all, I'm not able to do it because I'm not a resident of EU, and usually also not the hotels I'm staying in, like the network I'm using, they are not applicable for me because I'm not an EU citizen. But speaking about EU citizens, it means that actually any kind of person can just make this request and can find out what kind of data the company has about this person. And usually this is not quite simple because usually it works like writing an email to some kind of official representative of the company or to some kind of assistant of the company or something like that, or support of the company, and then this company may simply not answer or may simply look like they simply haven't seen this email, just not answer because it is complex for them and they don't want to answer this question. And obviously this is already a legal reason to go to court and say, okay, they are not answering my request, but usually this process is not a simple thing. And to actually find out what data do you have inside some kind of a system, you need to go through multiple steps. They are full of bureaucracy and other not really pretty stuff. But in ideal world, obviously, that should be some kind of a simple form where you write down what is your name, surname, and some kind of contact number, and after that, within a day, the company gives you the details of what data they have and how they store it, and they should say to you that yes, it is pseudonymized, we store only this and these details, and all of that is encrypted, and this can't be applicable if some kind of data breach will happen, your data still will be protected, something like that. And obviously GDPR doesn't end with just one audit. And this is also a very important point because a lot of big companies, they just do it once. They want to find out where they store personal sensitive information. They take a look at it, they decide to make some kind of decision, but they don't change their overall architecture of the system. And they do it just once, and that's it. And this is also not the right way, because GDPR should be always followed if the company is applicable for GDPR. Usually it means that the company is located in the EU. Obviously having some kind of data advisor, data privacy advisor, or data privacy officer on the permanent basis is very important, and changing the overall architecture of the system, if it is needed, it is still worth it. And as I mentioned, there are two kinds of data: sensitive data and personal data. And there is a difference between them, and also what OneTouch is doing, obviously, is that we are categorizing data into sensitive one and into personal one. So speaking about sensitive data, we're dividing it into a bit more categories, but here it is still the same, but just some categories are grouped. And as you see on the slide, personal data revealing racial or ethnic origin, political opinions, trade union membership, and so on, it is all sensitive data. And the main difference is that sensitive data should be protected even more than personal data. Because this data can be a reason for person discrimination. For instance, if someone finds out something about ethnic origin of the person, or something about somebody's disease, or something like that. So this data should be processed really, really carefully, and usually companies that store some kind of this data, they are really, really worried about how they are processing this data, where they store it, because if this data is stolen, it is a very big problem in the company. And personal data, it is simply the data that helps us to uniquely identify persons. So personal data, it can be, PII can be a synonym of personal data. PII is a personal identifiable information. So, for instance, my name, surname, and my phone number is personal data. And in practice, sensitive data, it is always personal data plus some sensitive information, speaking about practice. So, for instance, I don't know, my name and my phone number and my, medical records would be considered sensitive information, something like that. There are different ways, obviously, to pseudonymize it, to anonymize personal data, and so on, and I will tell a bit more about how can it be handled. And here is also some kind of a small chart about personal data definitions. Here are three main most important data regulations, I believe, that is GDPR, CCPA, LGPD. Obviously there are a lot of more of them, but these three are the most important, and usually other data regulations, they consisting of this kind of regulations, or they are very similar, something like that, but these three, they are usually mostly taken into account. So I described GDPR a bit, what is the definition of personal data for GDPR, and here is the definition of CCPA. As you see, it is any information to identify capable of being associated with or reasonably linked directly or indirectly with a consumer household. So it could be consumers' preferences, characteristics, trends, and so on. So translating it into a human language, it means that personal data definition for CCPA, it is even more wide, and it is even more informal, I don't know, simply saying. So it could be not even I don't know, some kind of personal data, I don't know, my name, surname, and passport number, something like that. But it could be also some kind of my characteristics that would help to indirectly identify me as a person. And speaking about entity types, that are needed for person identification in terms of GDPR and in terms of CCPA, for CCPA part, the number of entities, it is much, much bigger. And obviously the companies that should follow CCPA, they have much stricter rules. So CCPA is working only for California-based companies, as far as I know, and it was launched not long ago. And also, we have LGPD. This is related only to Brazil, And so, like, speaking about personal data, how it is defined, it is any information relating to identifying a natural person, and like there are no specific examples for it provided, so usually it is more connected to the GDPR definition. So I think that now we can come to a more technical part of the story and about data science challenges in data privacy field in general. So just to give a more clear understanding about what I will be speaking now is that I will not define some kind of challenges that are more related to model training or something like that. I will just give a general look into what kind of problems what kind of problems are usually the most important for data scientists when they are working in the data privacy field. So the first question we need to ask ourselves is that, is it needed to identify personal data? For instance, we have some kind of a data set that we can potentially build a model for, and we see that some piece of data there, it is, I don't know, for instance, generalized. I will speak about what is generalization later. And we really need to understand if we can make sense from this data if we are not doing some kind of their identification process, because the identification process, it is also adding some more components to our context. It is always giving our more latency and so on. Second of all, if we see that yes, we need to identify personal data because we can't make any sense from our data when it is anonymized, for instance, then we need to understand if it is really possible to do this kind of a process. And thirdly, so we can just find out what are the approaches to work on the tokenized data, like what we can do. So now I will tell more about the ways to do different kind of pseudonymization, anonymization, and other data protection approaches. So when we're speaking about pseudonymization, what it means is that we are replacing some pieces of the whole data that is personal, like in this case, with some random letters and numbers. Here we see that this arrow that is down below, that it is has this red line on it. So looks like this process is not invertible, and this gray arrow it means that we can't do reverse process. But in practice, if we are doing pseudonymization using some kind of cryptography or some kind of a similar way, in many cases we can actually do it. So this gray arrow, it is not always true, that it is that it has this red line on it. So it really depends, and the most important difference between pseudonymization and anonymization, as you will see now, is that for each string that is the same, we have the same output after we perform tokenization. So as we see for one gender, for the first gender and for the second gender, we still have the same outputs on the right, and that it means that for one input string, we have always the same output string. And for the anonymization case, we see that this is not true, and for one input string, we can have some random kind of output strings. For the case of anonymization, we can't do reverse process, and in most of cases, it means that we can't do any kind of machine learning operations on the data that is being anonymized. The next stages are suppression and generalization. Suppression, it was the most popular way, I guess, to protect data for the 90s and for early 2000s, I guess, yeah. And this is a pretty old way to simply hide the data from the people that shouldn't see it. And obviously we also can't do any kind of mail operations on it because we're simply replacing all the personal information with some equal letters, with some X's or with some zeros or something like that. As for generalization, this is a pretty good way, in my opinion, to hide the data. Like using generalization, obviously there are more possibilities for indirect identification of a person, because like if multiple fields are generalized, then knowing some kind of specific characteristics of the person, we can theoretically identify and reveal some kind of more personal sensitive information about the person. But the good thing about it is that using generalization, we are actually capable of using ML algorithms on it. And the last one is encryption and homomorphic encryption. So, as you've seen on the previous slides, sometimes tokenization can be synonym of encryption if we're using public and private keys for tokenization. And speaking about homomorphic encryption, what it means is that we can perform computations on homomorphic encrypted data without having access to the original data. So there are two kinds of homomorphism that homomorphism is usually referred to. It is a multiplicative homomorphism and that is additive homomorphisms, that are the two main types for it. And obviously generalized and homomorphically encrypted data can be utilized by ML models, as I described it earlier. Here are a few words about Python packages for data anonymization and tokenization, like the three most popular ones. So I believe that Faker is one of the most popular approaches for data tokenization, as long as it is pretty fast and this package is in general good. But one important point is that nowadays companies themselves usually are not doing the process of anonymization and tokenization if this is not the company that is specifically doing that. There is a whole market of companies that are doing specifically anonymization, tokenization, pseudonymization, and so on, and that have the products around it, and usually companies refer to them. So currently we need only to understand how the process is happening, but in terms of the price and in terms of how fast it can be done, in many cases it makes sense to work with some partners. And so, speaking about homomorphic encryption, I will dive in a bit more about what is the process. So here you can see some kind of a very simple diagram of like how homomorphic encryption is working. So what is homomorphism? That we are encrypting our message, like evaluating, doing some kind of evaluation on it, and then we're decrypting that, and we still are preserving our homomorphism. One important thing is that homomorphic crypto system, it is malleable. And malleability in this case means is that like the hacker can potentially, like in this schema, the hacker can use some kind of a breach in the system and then change some messages like to like that will make the person who will be decrypting it see different messages that were originally sent. In terms of cryptography, malleability is not a good thing. In terms of machine learning, it is definitely easy. And I will say some more words about different kind of encryptions and like just some words about what kind of homomorphism they are preserving. So RSA encryption, it has multiplicative homomorphism, so we are just selecting two large primes as we're doing here. Like we're choosing some encrypting and decrypting functions, and as you see on the last equations, we are having the case when encrypted x and multiplied by encrypted x2. It is the same as encrypted x multiplied by x2. The second approach, it is Gamal crypto system, and it is also multiplicative in its homomorphism. So we see here that this system is dependent on more parameters than the previous one. So here is also the proof of like the example that it is still homomorphic in terms of multiplicative property, but I will not dive into the details of this equation because it is simply mathematics of like multiplying like properties and addition properties of different variables. And the last example of encryption, of homomorphism in cryptography, it is homomorphism. In this case, it is pretty obvious that this algorithm preserves the operation of addition, and it is based on the least common principle, and the main function that is used here, it is LCM, that we see here, that is lambda of m. And so I will also not dive into the details of how it is working, because also the mathematics here is not very complex. We have one lambda function, we have one L function, and so on. And as we see here, this additive homomorphism is preserved. I don't think it makes sense to dive into the details of it. And now I will just show some kind of a diagram of tokenization and de-tokenization process. So usually, these processes, they may be different for different companies, but usually the overall idea, it is preserved. When data needs to be de-tokenized, the tokenization process, obviously it is happening. And the main problem with the tokenization is that usually this is not the fastest thing. And one important point is that depending on the type of the data that you have, you really need to think about how you are doing your data protection approach. If you are using anonymization, tokenization, some kind of encryption, and so on. So speaking about the tokenization process main disadvantages that I started talking about. If we are speaking about the case when the identification needs to be executed in the real time, obviously it means that in many cases we will observe high latency, and we need to think about how can we make this process as fast as possible, because ideally in the system it should work in a way that it is not visible. So the system should behave in a way that the identification process, it is that fast that it is simply not happening. That should be super fast in many cases. Also, another thing that, as I've said earlier as well, different anonymization, pseudonymization and encryption approaches should be used for different types of data. And what it means is that, for instance, for some kind of small pieces of data, it makes sense to use tokenization, like some fields in the database. And speaking about big chunks of text, for instance, some kind of big documents that should be protected, then it makes sense to use some kind of encryption approach, because in general it will be faster. Some time should be taken just to benchmark and to understand how fast what is the best approach to make it as fast as possible, and how fast can the system be using different approaches. So I believe that that's it from my side. Thank you very much for your attention and for your time. The last thing I just wanted to say is that now data privacy field, it is constantly evolving, and this sphere in general, it is developing from day to day, and even more regulations and rules and data breaches, they are happening. And in many cases, from the data science perspective, what is needed from the data scientist is not actually to understand the details of these legal documents and the details of this field in general, but it is rather understanding the main concepts of data privacy and understanding of the main challenges that may appear during the process. And also one more important thing that I wanted to note is that in many cases data scientists shouldn't have access to the real data, to personal data as well, because we're also human, and the process of data scientist accessing the whole data set that is simply personal sensitive data, a lot of these fields, this should be eliminated from many companies, because this is also the thing that a lot of different solutions, they are forgetting about it. So thank you very much, and thank you for your attention. So now I think it will be some kind of question and so on.
So, thank you for your talk, Halyna, and we have first 3 questions from our listeners. So the first question is, I'll read it. So, is there a way to pseudo-anonymize user-generated content, for example, user-uploaded photos or emails, or is it only possible through anonymization and Boolean masking replacing using named entity recognition?
Yes, thank you for the question. So, actually speaking about pseudonymization, in practice, the people who's doing that, they can think up about any kind of possible solution, I believe. So, the main quality and the main property of pseudonymization is that for each image, for instance, that will be pseudonymized, if the images are equal, then the pseudonymized images should be equal. So actually, yeah, the person can think up about blurring or about replacing some pieces of photo with some, I don't know, or black squares or something like that. But in practice, it can be done with any kind of approach, I believe. So there is no limitation for pseudonymization pictures, I guess.
Okay, thank you. And second question is, what is the best way of de-identification of personal data to save the quality of machine learning processing? Is there a way to not de-identify the personal data and use it for training models?
Yeah, so actually, as I've been speaking during the talk, the best possible way to do that is to use homomorphic encryption. And then to use the encryption that preserves two properties of encryption, which are multiplicative homomorphism and additive homomorphism. And then, like having these at least two properties, some kind of more or less good machine learning model could be created. So actually, I believe that this approach is the best one for speaking about not doing the identification. And one good example of that is, for instance, we already have the approaches to do logistic regression homomorphically because of some papers that are estimating this sigmoid, logistic regression sigmoid, using polynomials. So we are already capable to do that. And this is a big step in the industry. So I believe that after that, soon everything will be possible.
So we can using homomorphic encryption, we can encrypt our data and then just train models, embedding and so on them, right?
Yes, we can actually do that, but we should take into account that we, for instance, could have only two properties preserved, like addition and multiplication. We are not able to do some nonlinear operations like, I don't know, some kind of specific activation function, something like that. So we are not capable to do that unless we are estimating that using some kind of other way, for instance, like using polynomials in the case of logistic regression.
Mm-hmm. Okay. Short question. Could you please explain how encrypted text with P2PI used in processing in unencrypted form complies with GDPR requirements?
Actually speaking about PIIs, the requirement for GDPR, for instance, is to have it encrypted in a way that there shouldn't be some kind of data breach. So PII shouldn't go and flow through the traffic, for instance, like in some places of the system. And it shouldn't be stored without some kind of anonymization or pseudonymization or something like that inside the databases, like not diving into details, like it shouldn't like just be in the system and flow through the system, not being unencrypted, at least a piece of it not being unencrypted, and it shouldn't be there without some really important legal reason, because in many cases the only thing that is needed from PII, for instance, it is name and surname, for instance, to write some automatic response, automatic letter, something like that, in some email subscription, something like that. And actually there is no need to store this whole PII, so there is no reason in this case to store this whole PII. So it will not follow GDPR requirements if it will just be in the system and flow through it being encrypted.
Okay, thank you. And one more question. How is possible to prevent decryption of the leaked data if it's tokenized? something like storing tokens, private keys in some external cloud or delegating it to some security company. So how to prevent leak and decryption of encrypted datasets? I think this is the point of question.
So I guess I'm not really highly qualified to answer this question because this is already a question to security and to security software engineers and something like that. But like general response would be to just, as I've said during the talk, to start maybe working with some external company that would be doing tokenization, pseudonymization, and other kind of activities, and they would help doing that. But in general, this is a question like general cryptography and general security question, like where to store it better and where to store it worse. Like I can't advise some specific details on it. Like the only thing I can say is that usually, like companies, like in startups, if they are doing tokenization, they are doing it through some partners. So like they ask some people to help them, and they help with these activities. They usually don't do it themselves.
Okay, thank you. I see. Do we have time for one more question? Yes. So, next question will be from me. Do you have any specific examples when a company was issued under the GDPR? So, what did this company do wrong, and how did they find out about this? Because I don't follow the news about it, and I wonder if you know some funny or specific examples.
So I guess that the most like well-known example, like in the world of cybersecurity, is the data leak from Marriott. So Marriott is the company that is doing hotels, like something like, I don't know, some very expensive kind of hotels, very expensive network. I'm not sure if you have these hotels in Ukraine, maybe 11 euros in the center of Kyiv, but I'm not sure that they're from Marriott. Something like Hilton, actually. And they had their data leak, I guess, in January or February of this year. And it happened in a way that, like, I don't know the details and nobody knows the details, but usually it is some kind of either cybersecurity attack, like hacker attack, or it can be somebody just not storing the data properly, like in some kind of, I would say, not proper place, and it is very, very easy to stall it and just to reveal it using some simple commands. So in the news, there is no information usually about this data breach. It is just called data breach, and that's it. But yeah, usually it is happening now from some big flying companies, big hotels and something like that. Also, there was a case with British Airways the last year, I guess in the autumn of last year also. Like, they had very big fines for this data breach.
Mm-hmm. Interesting. So, I don't have any more questions, so thank you for your talk.